well, welcome. My name's Sean Devlin, and I'm a postdoc at the Biological Station. And welcome to Science on Tap Flathead. What this program is a chance for us researchers and scientists in the region to get together and with the community and to talk about our work, or to talk about issues at hand, or just talk about the lake in general or the region in general in a really relaxed, laid-back atmosphere, which I think we've nailed already. So starting 15 minutes late is exactly what we wanted to do. My hope is that this will afford an opportunity for everybody to sort of get to know what's going on at the biological station, as well as with the Flathead Lakers. So this is a dual sponsored event between the Lakers and the station in an attempt to sort of bring together what's going on around the lake in terms of both research and just total sort of wide open in terms of issues and anything you'd like to talk about. So it's really an outreach program to help folks get in tune with what we're up to, and more importantly for the Lakers and for the station to get in tune with what you folks are thinking about out there in the community. So a little bit about format. Again, sticking with a laid-back theme, we're going to have a very, very simple presentation or a talk for about 15-20 minutes with basically any kind of format is open to the presenter. They can do whatever they want. So some weeks, some months, we might have folks that do a small presentation with a PowerPoint and show some pictures. Hopefully that's at a minimum. We don't want to put anybody to sleep with PowerPoint right away. But really it's up to them. And then following a short presentation, we'll have a question and answer session where questions about the presentation and sort of offshoots that start up. And then following that, just a wide open conversation. At the end of the question and answer section, we'll see who's around and maybe have folks who are here from the station stand up and identify themselves, at least with a, hey, how's it going? And folks from the Lakers can do that as well. And that way we can sort of facilitate who you might want to talk to, or who's around that you could discuss whatever you have on your mind about. And ultimately what I hope this does is really bring us a little closer together so that you know what's going on with our two organizations and that we know what's going on with you folks. So that's the format. It's laid back. Along the way we'll have pauses for refills, which is important. That's exactly what we like, is someone walking behind me with 2 glasses of wine. I should mention a couple things right off the bat here, that the brewery has really been great. They've opened up this room for us. They've been very accommodating, even gone above and beyond, and made this event a fundraiser. So every pint that you purchase tonight, $1 gets donated to our two organizations to split. So that's a really amazing thing. Our contact at the brewery is Sarah Peterson. So if you have any questions about the beer or the food or anything like that, feel free to ask. We're really pleased and thank you very much for having us here. Perfect. This is what we like. That looks delicious. Laid back, relaxed, approachable. That's what we're after. So I would like to, now that you guys got your food, it looks great.
I'm going to cross the
show.
and then you can just finish up.
There we go.
All right.
Yep.
Here we go.
Wonderful. Cheers. I should also mention that this event is going to continue. It's not just a one-time deal. We hope to have this at least once a month. The first Tuesday of every month we'll gather. We have a whole list of ideas of topics to present. We don't have a set schedule yet. We're still in the infancy of that idea, but we're getting there. So we'll have presenters from potentially the biological station talking about either research projects or there could be a whole list of things that we have on mind. So I'd like to put out a call for anybody that might have ideas that you're actually interested in hearing about. You can. We have a website. It's called scienceontapflathead.org. you're welcome to go there and sign up, and you can email me, or I should introduce Hillary at this point, my wife Hillary, who's the Outreach and Education Coordinator for the Lakers. Email us and let us know what you're thinking. That's the key, or come up to us and talk. That's the other ideas. We'd love to hear ideas. We have about 12 ideas for 8 spots right now, so we'll have to decide what sounds the best, but we're really excited about getting this program started. And I can't think of a better way on December 1st of all dates for Jack here, to have Jack Stanford give a talk on how science can help the lake. I'm really pleased that he agreed to do this. He is now the acting director. I think that's important to mention, so give him a round of applause for Jack. It's a really important date for the station, and I think that it's a very important day for him as well. And I'm sure Bonnie agrees with that. He's going to give a talk that I have no idea what he might say. So the other point that I need to make at this juncture is that the presenters' opinions are their opinions alone. Especially important tonight, hopefully. But we hope to bring in some folks here that may say some things that get conversation moving as well. So that's an important thing to keep in mind. Jack's been the director, well, forever now, I think, just about. So I'll let him tell you more. But ultimately, I'd like to thank Jack for agreeing to do this. I appreciate it. And I'd also like to thank him on today for all his service to the station and for allowing me to be a part of it. And I think that it's a perfect venue for him to stand up here and talk about his time at the station, or whatever he wants. He's earned this half hour to say whatever he needs to say. So.
Yeah, Sean's a postdoc, and as of today, I'm a postdoc too. Well, great. What a crowd. Let's have some fun. Actually, I was driving back today from Washington, where we're going to live. We're going to keep our property here too, so I'm not gone from the lake. I always love this lake and work with the Lakers in the biological station for the rest of my life. So no worries about that. But it's kind of a long ways back from Twisp, Washington, where we're going to live. And as usual, I was working on the way back, and Bonnie was driving wherever I could get the internet. And one of the issues that came up was sort of a topic that I think I'll start with tonight. Many years ago, I grew up on the Gunnison River in Colorado, and I was always wanting to go fishing while my dad wanted me to work on the farm. And I spent most of my time fishing and trying to understand why these flies that we were mimicking fly fishing, what they were doing in the water. And the Gunnison was a great place to do that, because in those days there was a huge patch of salmon flies there. I mean, one that when they came out, they had been to bushes over into the rivers. You don't see that much anymore, because most of the rivers where big salmon fly hatches occur are changed now by dams and diversions. And during my college career at Colorado State, the government dammed the Gunnison in just above the Black Canyon, if you know that country, with a dam called Blue Mesa. Then they built 2 others downstream. And I think that sort of galvanized me to be thinking about, why wasn't there more discussion at that time about what those dams would do to that river? And particularly the resource,
so again, relax.
It's called the Black Canyon of the Gunnison.
There you go.
And so I'm going to have to talk to this thing. How do you turn it on? Okay, hello? Anyway, until it comes on, I'm going to just keep yelling at you.
It's on. No, it's on. It's on if you're speaking. It's on now.
Okay, so is that better in the back, maybe? At any rate, I was very interested in what these dams were going to do to the river system. And then as I got my degrees and went on up here to Montana to do my PhD work, I discovered these groundwater stoneflies that we've been talking about at the biological station ever since 1972, when we discovered them. My PhD student in here somewhere, Amanda Delvecchia, is still working on them. Only now she's really figured out what they do in the groundwater system, but that's not the point I want to make. I want to tell you about the interest that I had in how the distribution of organisms would change as a consequence of putting those dams in the middle reaches of a major river system. One that had endangered fishes in it, actually, the Colorado River pike minnow, as they call it. In those days it was a squawfish, but a really unique minnow that got to be 20, 25 pounds. Minnow, yeah. So it was a neat river, a really cool river, and a place to really look at how these dams might affect the river. In the time of getting my degrees and working here on the stoneflies of the Flathead, we began to realize that these bugs could really tell us a lot about how rivers respond to what humans do to them. And one of the early grants that we had at the biological station was with the National Park Service, was to try to figure out how to get the Montana legislatures and as it turned out, other legislatures around the West to provide to the state a federal reserve water right, or get the state to provide to the feds a reserve water right to protect the North Fork and the Middle Fork. And we were at loggerheads on that for a long time until the National Park Service started working with us at the biological station to show that these groundwater stoneflies that move from deep in the alluvial aquifers along the Middle Fork of the Flathead River at Nyack, that's where we did our work, and also in the Kalispell Valley, we showed that these things move around and interchange with the river all the time. And of course, the legislators that we took out on the floodplain understood what they were looking at, because they're from the West. They know about stoneflies in the river and that they're indicators of good water quality. And the point was that you can't pump water or change the river system along the North Fork and the Middle Fork without changing the character of Glacier National Park. And sure enough, that rationale right there, that science that we learned a long time ago during my early years at the station, was used to give to the Fed from the state a Federal Reserve water right for the North Fork and the Middle Fork. Those rivers are protected forever by that legislation. There was a big ceremony somewhere in DC or somewhere where all the mucky mucks signed the papers, and it was a big deal. And so there's an example of how the basic science resulted in I think, a measurable outcome for protection of the Flathead, because Flathead Lake, as I've said many times, is really clear and clean because of the protection afforded to the river systems upstream. Without that protection, Flathead Lake would not be what it is today. But let me go back to the phone calls and discussions that we had today about the Gunnison, because during the time that we were working on these groundwater stoneflies with the National Park Service, we were also trying to understand how those dams on the Gunnison River were affecting the endangered fishes in the river system. And what we needed there, because the dams were already built, was some kind of a flow regime that would allow power generation and all the aspects of what the dams were put there for, because they weren't going to go away, at least not in that system. And it became apparent that when you have a big dam that discharges water from the bottom of the reservoir, it summer cools and winter warms the water right below the dam. And very often in those situations you get a really blue ribbon trout fishery as a consequence, because it's like a big spring brook. And that's exactly what was happening in the Gunnison. But as you go downstream, because it's a dam built in an area that's historically much warmer and more silty and more like a more lowland river, as you go downstream, the river recovers many of its original attributes. And low down in the river system, down by Grand Junction, Colorado, the endangered fishes were still doing pretty good, still hanging on down there. So the issue was, how do you operate the dam in such a way that the fishery will be maintained, the sport fishery will be maintained, and also maintain the Colorado River's endangered fishes, squawfish, humpback chubs, and others. Those are still not recovered fish, but they're still hanging on in the Gunnison. So we did this long temporal study, long study, sampling way up at the headwaters of Gunnison, sampling at stations all the way down to Grand Junction. And what we learned is that essentially there's a discontinuity created by the dams, as you might expect. The areas below the dams, because they are cold in the summer and warm in the winter, sort of mimic the areas in the headwaters, believe it or not. And so you had this sort of reset phenomenon that we called a serial discontinuity because there were multiple dams. And as time went along, we were able to show what kind of a flow regime would be needed from the dams to sustain both the trout and the endangered fishes. And in 1978, a colleague and I that was working with me recommended a flow regime for that river, and based on our studies, and also based in part on what we've done at the biological station. And the Park Service endorsed that. But then they were sued by the irrigators and other dam operators because they wanted more flexibility than what we had proposed. And this thing was in court for 25 years. And then finally, what we had recommended won out because the science was so strong, it eventually won out, and that was implemented in about 2001 or 2. And what caused me to think about this is that I happened to talk to the, come on in, Charlie, and I happened to talk to the Park Service guys that were a part of this, and they told me that sure enough, the recommendation that we made had been implemented and had been running that way in the river system ever since. And that the fishes were all doing fine, everybody was happy now, the irrigators were happy, the Denver Water Board was happy, everybody's happy. So another outcome that began as a basic science inquiry and then leveraged out to a problem that was important to, I think, the people of western Colorado. Now when we got that Federal Reserve water right for the North and Middle Fork, the Park Service was working on other parks to protect them. And the same thing happened in Yellowstone, and believe it or not, it happened in Zion National Park too, on the Virgin River. Zion is a park that sort of, its headwaters are not part of the park. The Virgin River in Zion is not part of the park. But downstream you have the park, goes through all those big slot canyons and that beautiful country down there. And then it goes out into irrigation country and is basically used up by irrigation. But the point was to get a Federal Reserve water right that would protect the Virgin River flowing through the park. And we used the same rationale, bugs and fish, didn't work. The Utah legislature weren't interested very much in bugs and fish, and so we tried geology. Well, how could you have this beautiful park if you didn't have the river that was cutting through it to make the canyons? And if you dam up the rivers upstream of the park, you would change the character of that park. Didn't work. So we were sort of at loggerheads, and I thought there's got to be something here that we know about this river system that will relate to this Mormon legislature. So one day I'm sitting by the river with a Mormon ethnographer, really nice fella whose business was to understand and document the history of Mormon conquest in southern Utah. And he said, you know, when the Mormons first came into this country, they always settled under these big cottonwood trees. We were sitting under some big old growth cottonwood trees, and I said to him, well, in about 50 years you won't have any because these are not going to reseed if you dam the rivers up above, because cottonwoods seed during flooding. And if you take the floods away from this river, you won't have any cottonwood trees. Well, that did it. That did it. And Zion National Park now is protected for its virgin flow in the Virgin River as a consequence of the Mormons' relationship to the cottonwood trees in Utah. So you see, science can help bring people together in a very positive way. So that's sort of my story for tonight. I can talk to you about anything that's on your mind about Flathead Lake, but we have had many outcomes on Flathead Lake that were important. I'll just tick off a few where the science really generated the outcome. it took a lot of talking. It took microphones like this and public discussions like this and over beers on many occasions for many different reasons. But maybe one of the first things was the detergent, the ban on sale of detergents and sale on phosphorus in detergents, because at that time our studies really indicated that the nutrients phosphorus and nitrogen were a problem for water quality in the lake. And I know that Ed and some of you that are in the room remember the controversy over us saying you need to take the phosphorus out of detergents, and Procter & Gamble said, like hell we will. And they came to town. Remember those days in the auditorium in Kalispell where the consultants for Procter & Gamble said these local so-called scientists are full of detergent. And they're wrong. And remember the guy said, the phosphorus that comes in Flathead Lake should be coming from 6 cows. And I went, I can't believe he said that. And of course, took it from there, and I thought they were going to run them out on a rail, but the local folks. And so it was implemented. The first time in the country, actually anywhere in the United States where that action happened. Today you can't buy anywhere in the country phosphorus-containing detergents for laundry use. You can for dishwashers, but it helped. And it went from there to upgrading the sewage treatment plants, and then Cabin Creek came along the first time, and then we sort of put that to bed with the help of strong interactions from everybody in the community, the Lakers and everybody else. And of course, Cabin Creek came back 20 years later, and we sort of went through it again. There's always going to be some kind of problem, threat to a lake like this one, an ecosystem like this one, because it's so rare. Right now, I'm really concerned about the oil trains on the railroad along the Middle Fork. One of those into the Middle Fork, and it will come all the way down to Flathead Lake. We've got to keep Burlington Northern on their toes. I really believe they're trying to do everything they can within the framework of the engineering of railroads to prevent that accident from happening. But accidents happen, and this is one place where it can't happen. I did a calculation for a First Nation up in British Columbia not too long ago, where they were concerned about a pipeline that up there was called Enbridge, where they're going to take tar sand, heavy crude, through a pipeline through the mountains of British Columbia to the port at Kitimat, which is in the fjord country of British Columbia, load that heavy crude onto tankers and try to negotiate the Estevan fjord country out to the open ocean. This is crazy stuff. There's no amount of profit that could come from something like that that would offset the potential damage from something like that. So the issue that I had to take a look at is, well, what would happen if there was a spill into the Skeena River system just between 2 check valves on the proposed pipeline? Well, this kind of stuff, this heavy crude contains all sorts of compounds in addition to just the fuel aspect of it, and one of the primary compounds is benzene. Benzene is extremely toxic and carcinogenic, and we showed with a very simple calculation that just a spill between the 2 check valves into the river would send a plume of benzene above water quality criteria all the way through Prince George from the mountain country of BC. So that's what would happen here if there's a bad spill of that crude. And I don't know, Charlie, if it's Bakken crude or tar sands crude that's on the railroad. They're not very open about that, but it's one or the other. Either case, it's not good. And so we're working right now with Burlington Northern and the National Parks Conservation Association and others to try to begin to understand what would happen if we did have a spill. How rapidly could action to try to stop it be implemented, and the only way I can see to do that is to use some of the models that we've developed at the Flathead about how this stuff would disperse, and apply it in a sort of a mathematical scenario way so that we can train the response people as to what they're going to deal with. It isn't just going to be sponging up the heavy stuff off the top of the river. It's also going to be years and years of trying to restore the alluvial aquifers where the dissolved bad things will go into solution and be entrained and held up. So that's one that worries me. Otherwise, the studies at the lake are really robust, and the new regime that's coming into the biostation is really uniquely equipped to take it to another level, take the understanding to another level. And I look forward to watching the station and Flathead Lake continue to have a very strong relationship and even mature more than it has. So those are the things that come to mind tonight. I think you should ask me some hard questions.
So there's benzene in suntan lotion. Do you have any thoughts on?
I wouldn't put it on my stand. I don't know what it is. You'd have to show me the ingredients before I can respond to that intelligently, but I doubt if it's straight benzene. It's probably some derivative. Why it's in there, I wouldn't know, but benzene is a bad compound.
And it's not all of them, but I won't use it.
Can't answer that, but she got me on that one. Haven't been analyzing suntan lotion. What's on your mind? Anything? Come on. Yeah, Charlie?
Well, like the suntan lotion, I don't know the problem. If you don't put it on, you have X amount of risk of skin cancer. There's trade-offs everywhere.
But there's
And
zinc oxide also. There's
yeah.
other types than benzene for.
I'm not getting. That's not the point. The point is that we're faced with a lot of trade-offs, and one of the trade-offs, if we are going to ship oil, and I would guess everybody in this room used oil to get here tonight, I did. If we are going to use oil, and if we're going to, it doesn't come up in every town, it doesn't come up at the gas pumps, it comes up in relatively rare places in the Earth's surface. And pipelines have a much better record, spill per barrel shipped or whatever, than railroads. And I live on the side of the lake down here, Route 35, and we got lots of trucks going by that I understand didn't used to go by. I don't know this, because apparently there was a pipeline on the other side of the lake, and people didn't want to have a pipeline. So we're having all of these trucks, and I've watched so many people crash. One crashed right into my driveway, the tree at the edge of my driveway the other day. I don't know how come she wasn't killed. But all of this is what are the trade-offs? And you can't, well, maybe you can. If you want to say, no, we don't want anything, then the issue is development. And maybe, as I've said before, I think that is the issue in the Flathead. But that's a difficult one for people to talk about. But the question is, we just can't say we don't want a pipeline, we don't want to have oil cars in trains or on trucks, at least so far, because if we say we don't want this, then it's coming down this highway in front of my house in tanker trucks.
Or it's on the railroad. Yeah, all of those things. It's a matter of balancing things, using the information as best we have it, being honest about what's in the rail cars and preparing for the worst, expect the worst, and hope for the best. And that's what we have to do. The railroad has always been along the Middle Fork, and it's not going to go away. I think there's going to be trains on it. Charlie is a world export. World export? We've tried to export him multiple times, and he keeps coming back. No, he's an expert on energy and particularly on oil, written a number of books, very interesting books on it, so he knows what he's talking about. Yeah, Ed.
Have you done any study about the onset of the climate change in terms of the demand that may or may not be changing for energy that's produced by the dam which I can't say anymore because I don't know how to pronounce those words. But and the effects that may happen with the lake level, then in terms of erosion that could occur, particularly up here on the North Shore.
Yeah, we've done a lot of work trying to project climate effects, climate warming, what it'll do in this system, and the gist of it is that we'll probably have more rain-on-snow events that could be pretty flashy in the wintertime, although one of the biggest floods that ever occurred in the Flathead occurred in the winter before records were really kept. Well, a rain-on-snow event. So we expect things to be a little different here, but not as different as it's going to be, for example, in the Southwest. I'm working with the Walton Foundation down there to try to develop a model that will help predict what's going to happen to Lake Powell and Lake Mead and the so-called Central Arizona project that takes water from the Colorado River Phoenix area, and the Southern California Metropolitan Water District that takes water via the California Aqueduct over to Los Angeles. And they're predicting that there won't be enough water to go around by about 5 to 10 years from now. So it will be extreme down there. Our effects, I think, will be much more subtle and limited. It's already been a lot of warm winters, but you never know. It got cold this year, pretty cold. One of the things that worries me on a global scale of the concerns that you're expressing is this tremendous cooling of water in the North Atlantic from the melting of the glacial ice in Greenland, because it's the physics of that water, the way in which the warm Gulf Stream interacts with that really cold water that's in the North Atlantic that drives the Gulf Stream. And if the circulation of the Gulf Stream should change, big things are going to happen. So, and that's not a preposterous thing, given the vastly quickly spreading cold water in the North Atlantic. That's the best I can do tonight, Ed, on that one.
Can I add just something? If you really care about that, see me afterwards. We've just finished my 12th book, which is on where you want to live in the United States as a function of expected future environment and resource issues.
Well, if you want to catch salmon, we did some work that shows that the rivers that used to freeze solid in the winter that flow into the Arctic Ocean are already being colonized by salmon. So I recommend investment in a salmon lodge up there.
So now that you're sort of retired, what's your no-nonsense assessment of the water quality in Flathead Lake, and where do you see that going? And this is the more recent trend, not the 50-year trend.
Yeah. So I came to this lake the first time in 1971, and I had to stop my car and get out and look because the water was so clear for a big lake. And we've said many times this is the cleanest big lake in the world in terms of one that's at least in the temperate regions that has a lot of people living around it. And that's because of the tremendous quality of water that fluxes out of Glacier National Park and the Bob Marshall Wilderness. That's the major source of the water budget for the lake. So if we continue to take care of how we do business around the lake with our sewage systems and how we push soil around and that sort of thing, and I think through the Lakers' actions and the work that we've done over the years, it's in really good shape. There is a very good understanding of nutrient retention in forest lands and ag lands now, and the way in which developments are being made to retain hard surface runoffs. All those things are on the table all the time, and the water quality in the lake hasn't changed that much. The actual clarity and the chemistry of the water hasn't changed that much since I first came here. And I don't expect it to change much in the future. What has changed, though, is the food web. And you all know the story already about the mysid introduction. And I saw Tom running around here with his display case of zebra mussels, or one of the mussels. Yeah, that's right here. And if that thing gets in the lake, then it will be a big change. And I really worry about that and oil spill more than I do about the original concerns that we had over nitrogen and phosphorus coming into the lake. Now, one thing that's really clear in the long-term data is that nitrogen loading is gradually increasing. And that's because nitrogen loading in the atmosphere is increasing globally, not just here, but everywhere. So every lake in the country now is exporting more phosphorus, more nitrogen, is exporting nitrogen, not retaining nitrogen the way they used to. And so phosphorus is becoming more and more of the limiting nutrient in terms of productivity and reducing the water clarity. So you might begin to see more and more clarity in the water as a consequence of lack of phosphorus in the system, simply because nitrogen is becoming so abundant. And Sean there is modeling that and trying to make predictions about how the food web would interact with the way in which nutrients are cycled in the lake. So it's a great lake. It's one just impossible to overstate what a resource that it is because of its clarity and its I wouldn't hesitate to drink out of the lake any more today than I did when I first came here. So.
When we bought our property just south of here, a couple miles, in 98, there was very little or no algae on the shoreline. And especially in the last 5 to 7, 8 years, we noticed more and more algae, different colors, so I'm assuming it's different species of algae. It ebbs and flows with the amount of wet spring runoff we have. So I hear about the water quality hasn't changed that much. I guess my question is, what is the impact of sewage treatment, more specifically septic systems? And do you think that the algae that we are seeing right on our shoreline, and if you paddle north or south, not several hundred meters, you don't see some of the same algae. Is this more specific to what we're contributing in our septic and the septics above us, or is this just a collection of nitrogen from all over?
Yeah, it's a ever since I've been here, every few years when we have a talk like this, someone will come up and say, oh, the algae in front of my house is so bad this year. It's really bad. And we've done a number of studies around the lake where we use what years ago we called a septic sniffer, which was if you'd use a fluorometer, it will excite it will cause the detergents to fluoresce if it's breakout from the septic system. So we can easily determine if there's a breakout or a septic issue in your spot. It sounds like it. Years ago, on the shore of Polson Bay, there was a big mat of algae down there, and this was 25 years ago, I went down with the local Polson manager. I said, it looks like sewage, it smells like sewage. I'll bet your sewage main is broken right there. And sure enough, it was. So local problems where you see an intense bloom probably means there's a local source of groundwater that's either, groundwater's got much higher nutrient content naturally than the lake shore, than the lake does. So that will cause it to bloom. It does that right at the biological station there where there's a natural input of groundwater. But if there's a septic problem, maybe your system's not working so good or your neighbor's is not working so good, that's what you will see. Now, having said that, we keep a long-term monitoring record of the growth of algae on the shoreline by measurements that we make on the Horseshoe Island down by Bird Island and at the biological station on the peninsula away from where there's any kind of sewage or anything. And it really doesn't change much from year to year. So the ring around the lake, as we used to call it, the ring around the lake, is a phenomenon that we live with because in part of the fluctuation of the lakeshore by the dam. That also interacts to some years produce more algae than others, depending on how fast or how slowly the lake was drawn down, how fast it came up, what sort of runoff year it was. So your observations are all right, and you might take a water sample down there and bring it up to the station and see if it'll fluoresce. If it does, you probably have some detergents coming out on your shoreline. Oh, you want me to go there? That's the one issue that they tried to cut us off at the knees with around here. He's asking about lakeshore erosion. And you probably know that there's a class action suit that's been in the mill for many years suggesting that dam operations could be done differently to reduce the amount of shoreline erosion that we see around the lake. And many of you that are homeowners on the lake have given up on that and just put rock in there to revet the lake so that it doesn't erode your shoreline. Or maybe some people have installed passive gravel beaches that were invented at the station by Mark Orang and are now implemented in partnerships with the Lakers, I believe. At least there's a way through the Lakers to learn how to put one of those in. But the point that I want to make is that lakeshore erosion has never stopped. It's still continuing, and at the biological station, it's particularly problematic. We keep losing our big pea pines to the lake as a consequence of it gradually moving back. Now, the PP&L company that operates the dam has long claimed that erosion stopped about 25 years ago, and they've managed to find some consultants that say that that's the case. Well, I don't say that's the case. I think it's continuing to erode. I think we have measurements. I don't think you need to measure it. You can just walk to just about any place on the shoreline and see it, particularly if hard structures have been put in that accelerate the energy of the waves coming in down the hard structure to the end of it and then erode in-cut around the end of it. So that case is still in the court system. I understand that it's been appealed by PP&L back to the Montana Supreme Court. I don't even know at this point what would happen if the case was settled in the favor of the plaintiffs, in the favor of the company doing something about the erosion. And it's also complicated by the fact that the dam is now owned by the tribes. So this one is probably going to continue for a while, but what we need to keep in mind is that this passive gravel beach process really works. And so if you only own a few hundred feet of a shoreline that's eroding, you can stop it dead by adding upland gravel. Don't take floodplain gravel, but upland gravel onto the shoreline, and it will reduce the wave energy enough that it won't erode. Now, if you're at the biological station where we own 2 miles of shoreline, it's a different story. Cost us many millions of dollars to do that around the whole shoreline. So the biostation kind of caught on this shoreline erosion thing. The one thing that's for sure, and we showed this years ago, another example of the science coming into play in terms of actually settling the controversy. We showed that if you reduce the lake full pool level by 1 foot, it would reduce the energy striking the shoreline by 70%. Duh. But reducing the lake a foot is a tremendous amount of water that would otherwise go through the turbines at Polson. So there you have it. There it is. It's a controversy that's going to continue for a while. And any time that shoreline begins to erode as a consequence of unexpected storms, particularly at full pool, and it reduces the clarity of water, that's a direct impact on water quality, and it's directly a consequence of the way the dam is operated. Is that blunt enough?
What's upland gravel?
Upland gravel means you're going to take it from a gravel pit like up here north of Big Fork, where it's not intersecting the water table. It's It's ancient deposits of gravel from the glaciers that is being mined up there. It's also mined down by Woods Bay. There's another couple of mines up by Coram. What we don't want to do is mine gravel in the Kalispell Valley floodplain, where it's being mined extensively, because you're destroying the matrix of the aquifer there that's filtering the river water as it passes from the mountains and from Columbia Falls and Whitefish and Kalispell. It passes through that aquifer, and that process cleanses it, reduces the organic matter that's in it, and sends down clear, clean water. So by mining in the floodplain of the Flathead River, we're actually undermining the way in which the lake is maintained. So I've constantly, for years, we've been after the state to better evaluate where gravel mines are being placed. So upland gravel is safe gravel. Floodplain gravel is counterproductive for what we're trying to do in maintaining the quality of Flathead Lake and the river system too. Moreover, there are very interesting critters in that aquifer that still need to be named, and things that really cause scientists to get excited.
So is it bigger? Is that why? Is it bigger? Is that why it doesn't wash the shore?
No. It's all outwash gravel. It's from pea gravel size up to cobbles in both places, on the floodplain and in the uplands. It's just that by mining in the uplands, you're not tearing up a part of the ecosystem in a way that's negative for the values that we're trying to protect. So no, it's the waves. The waves come in after you put that gravel on the shoreline, and they cause it to move like marbles, bouncing off of each other, and that shakes away the energy of the waves, so it doesn't erode the backshore and carry the big sediments out into the lake. Yeah.
Charlie, what's the name of your 12th book?
How I became a systems ecologist.
No, it's the one about energy and where you want to live.
Will you please write your email? I've been editing it all day.
You can't even remember the title of it.
So, can you give me your email and I would...
What's it about, Charlie?
It's looking at what we call megatrends, what we perceive to be the environmental and also economic trends projected over the next 20 or 30 years and more. And the idea is that something like 30 million Americans move each year. And you can look in the retirement magazines and so forth, but most of the places you want to move to might make sense today, but are unlikely to make sense in 10 or 20 or 30 years. And what it really is our means to try to get on a very large scale the kind of things Jack talks about in a form that's palatable. It's my first attempt to write a non-scientific, well, it's scientific, but a book for a general audience. And if you're thinking about moving, but on all of our maps, we've got maps of every hazard you can imagine. And well, here I live, this place doesn't look too bad, except it's so damn full of people.
Oh, come on. Those of you that don't know Charlie, he worked at the biological station a long time ago when he came from Cornell to us, and then he went to SUNY Syracuse and has been a well-known professor there for many years, and is now retired back here to the Flathead. So it's great. Yes, ma'am.
Could you tell us Charlie's last name so we
Okay.
just look it up on the internet?
She wants to know your last name.
Or the name on your book?
Hall. It's John Day and Charles Hall, and it is, oh my God, it's something and then a journey across the American landscape. Please, I will send you I just got a file, I can't remember the name. And I've been working on it all week.
I see why it's a song.
Or you can email me, chall@esf.edu. CHALLNESF.edu.
And Science on Tap will be expecting an advertisement fee.
Well, I'll send it out to the Lakers.
There you go.
Jack, I'd like to go back to the train.
Back to the train.
Can you talk a little bit about anything you know about this issue of whether or not we can really respond to one of these things? What are we doing to determine how long it would take if there was an accident in the Middle Fork for the oil to go downriver? And how important it is for us to either improve our response time to an accident or try to prevent any accidents at all?
Yeah, so he's asking about what I know about how fast the people that are responsible can respond to an oil spill on the Middle Fork, and also the trade-off of prevention versus being prepared. We have to depend on Burlington Northern to be as prepared as they possibly can be. And that track is a modern track today compared to the old days when it used to dump lumber in the river all the time. It's a much more modern track. It's constantly being monitored. But there are places along the Middle Fork where the river is very close to washing the tracks out at times. And if we have a sudden flood, there's ways in which that thing can spill. So we've asked Burlington Northern, what's the response time? How are you going to do it? How are you going to deal with the volatiles versus the heavy stuff? How are you going to deal with the dissolved stuff? Do you know where it's going to go? And they're in the process of trying to develop a robust plan for how they would respond and interact with the local civil defense people to be as proactive as possible. What we want to do and what we want Burlington Northern to fund, because we'll learn a lot about the river system by doing it, in addition to learning how fast people can respond, we want them to let us do essentially a spill of non-toxic chemicals, be a dye, plus some kind of a conservative tracer like bromine or something that's completely harmless. And then we can track those things through the aquifer system, through the river system, and we want to do it on our own terms. We want them to fund us to do it, but we'll do it. We won't tell them when we're going to do it. We'll take a tank car to put enough into the river to do this so we can see it. We want to be able to see it with the dye, and we want to be able to track it with the chemical tracer that we can then detect with sensors that we put in the aquifer system at Nyack and then various places downstream. And they're thinking about it. We're working with conservation people on it. And my prediction is that if we did that in a way that it was unexpected, that the response would be pretty slow. Too slow to prevent it from going a long ways before it can even be addressed. So that's the purpose for doing this, to give people a chance to see how good they can be at getting booms out there and other things that might come into play. Remember that one of the remediations for these kinds of spills is to burn it off. Well, you aren't going to set a oil spill on fire in the Middle Fork in the middle of the summer like we had last summer, I don't think. So there's lots of things that are going to have to be talked about openly, and I'm just publicly constantly encouraging Burlington Northern to come to the table. It's a big company. They have plenty of resources. The most critical place on their entire track network, in my opinion, is from Marias Pass to where it goes over into the other side past Whitefish there. So we got to keep after them, and they've been pretty forthright lately about talking about it. We haven't seen their models yet, about their spill models. We want to see those. We want them to see our models. I think there's a big disconnect between the two of them, because one is a one-dimensional flow model, just following the river. Its basic driver is the flow rate of the river, it's not a transient storage model where materials are stored here and there differentially. Some stuff's going to go right down the middle of the river. Some stuff's going to go to the shoreline. Some stuff's going to go in the aquifer. So which is going to go where and how fast?
to follow up on that, I mean, surely prevention is enormously, as we, all kinds of stuff that I've been somewhat involved with in the Gulf of Mexico. An ounce of prevention, my mother told me, is worth a pound of cure. But I have a question for you. When you talk about you might have a high flood that undermines the tracks, and I've certainly thought about that when I've been driving along there, do they have sensors on the tracks or in that vicinity that would send a signal when this erosion might take place?
Now, I can't answer that for sure, but I think the answer has to be yes, because they know where their trains are all the time. There's some kind of sensors along that. It's a continuous rail track now, so it should be.
But do they have one looking down at the river?
No, they would only know when their track was disconnected.
Yeah, right there.
But at least we can show them through our models where the vulnerable points are for the whole track system, and we need to do that.
How healthy is the Swan, and what's its contributions to the whole?
Swan Lake, Swan River, both. So he's asking how healthy is Swan. The water quality in Swan Lake is very similar to Flathead. It's the same deal. You've got mostly really clean water coming into Swan Lake. The water quality is virtually identical, so it's in great shape. Whitefish Lake is a little bit more problematic because it has a long history of pretty bad abuses along the shoreline. There's a tremendous amount of sawdust, for example, in the bottom of the lake. So it's not as good a shape as Flathead and Swan. Swan's a great lake too. Again, there's food web issues over there, food web changes over there associated with kokanee, lake trout, that whole thing. Yeah?
Jack, as you have so many times in the past, you've helped us understand how basic science is contributing to the betterment of this area. You've been at it for 30 or 40 years. What can you say about actions that the public can take that have been supportive of the things you and the biological station have been doing, and that in fact, where you see action on the part of other parts of policymakers, what can the public do? Obviously, you've got a group here who's very concerned and interested about the lake. It's a much larger group than this. Where have you seen progress, and what sort of actions have you seen being effective?
Well, the quickest answer to the most obvious answer to your question about how is this science of the biostation interacting with the public is via the Flathead Lakers. The Lakers have always been our staunch ally, and we've always tried to make our results and our understanding of the lake relevant to them in ways that they can then pass it on to the public. The other thing that I would say is that in the history of my time here at the lake, which is over 40 years now, I've always seen this community around the lake come up, step up big time whenever there's an issue. I've seen auditoriums full of people interested many, many times in my career, and I expect that will continue. So the main thing is to encourage your neighbors, and especially new people, to understand what we know about this system, why we know it, and why it's so special. One of the difficulties that I see as I travel around the country and now internationally, and Charlie does this too, all of us do some of it, is that in many places their baseline is off, meaning that they don't have an appreciation for two things. One, what the system once was, and secondly, what's called faith in nature. That if you will leave things alone and let nature take its course, very often that's the best way to restoration you can possibly have. And that's certainly true here. What we want to do is keep this system intact ecologically so that it can function on its own without intervention with some sort of activity on us to try to fix it. I am deeply involved now in salmon ecology, not so much here, but around the Pacific Rim. And next Monday I will be in Sacramento talking to people that are attempting to restore salmon in the Sacramento River system, which is just about totally destroyed by dams, diversions, irrigations, pollution, on and on and on, you name it. the plan is to try to recover Chinook salmon in the Yuba River by catching the adults when they come up from the ocean, putting them in trucks, hauling them around the reservoirs and dams to the headwaters, letting them loose, expecting them to spawn, catching the juveniles when they come back downstream, carrying them in a truck or around the reservoir back to the ocean and putting them back. This is deemed salmon recovery. I have another word for it. They might as well fly over the Yuba River and dump out dollars. It would be more productive for the people that live along it. It's not going to work, particularly under the climate change scenarios for that particular river system. There are some places where the baseline is so shifted that putting it back together, absent taking the dams out, is simply impossible. So our argument would be to the NOAA, which is the National Oceanic Atmospheric Association, National Marine Fisheries Service, that's responsible for recovery of endangered fishes like Sacramento River Chinook, that you've got to have a dose of reality here. There are some places where you can put millions and millions and millions more dollars and not getting any return on your investment. And that's one of the places where it's going to occur. Now, in contrast to here, when I go down there, my opponents, the other side of the fence, who's proposing it, supporting NOAA on this, are American Rivers and Trout Unlimited. Now wait a minute. What's going on here? Those are two premier conservation organizations. What are they thinking? I'll answer that when I get back, I guess. I don't know. It's local members wanting to catch trout. So. Yeah, Teal Hillary. Yeah, please, if you need to go, I mean, get more beer, go do it. Hillary.
Sean and I have done a lot of field research over the years, and it seems like everything always goes wrong when you're doing field work. Do you have any stories from your 35 years? This is more lighthearted. Things going wrong.
Yeah, the problem with being a scientist is that sometimes Mother Nature doesn't cooperate the way you think it does. And you can be wrong a lot of times, but you learn from being wrong. That's the key to it, that you learn from being wrong. That's the way we do it. We propose a hypothesis, we go out and try to test it by making measurements in the field, and it's okay to find that your hypothesis was wrong. The one most classic type 1 error I've ever talked about around here is the introduction of mysids to Flathead Lake. That was done under the thinking it was going to be great for kokanee. Well, kokanee are gone now, so that was a bad one, a mistake. And but we've learned a tremendous amount about how food webs work as a consequence of that activity. We don't want anything else in Flathead Lake, but Hillary, that's part of the fun of being a scientist. To go out there, trip up, and when your nose hits the ground, you look back and see what you tripped on, then you look and see what's in front of your nose. And what's in your front of your nose might be the next big discovery, like these groundwater stoneflies that I happened upon many, many years ago that sort of defined my career the whole time. Are you up here to take control?
This isn't an end to the fun here. It's a call to. So I should mention there's many science on taps around the country, and one of the biggest. So setting this up, I asked around like, what are some of the pitfalls? Like, what happens? And we fell into the classic trap, which is empty glasses. So, if anybody's in need of a beer, we're going to take 5 minutes here. Feel free to place an order, go up to the bar, get a refill. I need one. I think that I maybe I'm about 10 minutes, 15 minutes late on this announcement. That's all right. So then we can either continue with questions and answers if Jack still has a voice, or we can proceed to just a general conversation and mill about and see what happens. Well, let's take 5 minutes and get refilled up and use the restroom and try and reconvene in about 5 minutes, and we'll see where we go from there.
Thank you.